Hi everyone, welcome to our video on evaluating linear functions. So linear functions have the form f of x equals mx plus b. So remember, when it's f with the parentheses like that, it's not multiplication yet, it means f of x. And so what we're going to be doing is subbing in an x value or a numerical value and changing those x's into whatever numerical value they want us to change it into. And then from there, it will turn into an order of operations problem. Notice that the linear function form, so the first four letters there, is a line, and we might remember that our slope-intercept form of a line looks like that. So with the y equals mx plus b, let me just write all of that in there. So the slope-intercept form of a line. And then from there, we could graph it. So we use this form mostly to graph. However, these are the same. So f of x equals mx plus b is the same as y equals mx plus b. They have their different advantages in their different cases. So for instance, again, this bottom one, the y equals mx plus b, is usually better for graphing. This top one is usually better to evaluate and to know what our independent variable is with our dependent variable. Okay, so we have our independent variable is x, and then our dependent variable would be y. So just in case we need that vocab, so y depends on what x value you plug in. Okay, so that's why it's the dependent variable. Okay, well anyway, let's see how we can do these types of problems where we are just going to evaluate. So let f of x equal 2x minus 7 and g of x equal 5 minus 3x. So it doesn't always have to be f, it could be g. They could do whatever letters they really want to. It still breaks down the same way no matter what. So when we're going to evaluate f of 10, what they want us to do is take our function right above and change those x's that we see into 10s. Okay, so this is already changed. So x is already 10 here. And then we just need to change that one into 10 as well. And then always use parentheses, because from here we'll use our order of operations. So this is 2 times 10. So on the left, we're just going to rewrite. On the right side of the equals, we'll do our order of operations. So 2 times 10 is 20. And then afterwards, we'll minus 20 and 7. So 20 minus 7 is 13. So that's it. So that's our answer. Okay, so that's the evaluation of it. What this does, it does represent a point if we were wanting to graph part of it. So that is an x value, and what we just found is the y value. Okay, so we would have 10 over here somewhere, and then up 13. Like that. So that's just the one single point. However, we would know if we needed to graph this, it would be a line. It has a slope of 2 and a y-intercept of negative 7. So we could continue graphing if we really wanted to. Okay, however, our focus is still just to evaluate. So the 13 is the answer. Okay, and then with negative 4, again, we're just making sure we're plugging it in the right spots. So they're saying change those x's into negative 4s. So we have f of negative 4 is 2 times negative 4 minus 7. And then still continue with your order of operations. So 2 times negative 4 is negative 8. And then now we can do the subtraction. Negative 8 minus 7 is negative 15. There we go. Okay, and then they might throw some decimals in. That's okay. So we could do that. So if they put decimals in, it's still just making sure to change the x's into whatever number they want us to. So we'd have 2 times 3.7. So we've got, let's write our second line. So f of 3.7 is, well, 2 times 3.7 is 7.4. And then afterwards, we'll just have to minus 7. So we've got f of 3.7 equals 7.4 minus 7 would be 0.4. And there we are again. Okay, so there's our evaluations so far with f. Now in this problem, they also gave us a g function. Well, it's still just going to work out the same way, except instead of using the f function, use the g function. So g of negative 6 means to change the x's that you see in this equation. So that x right there and that x right there needs to become negative 6. So the left side, we've already done it. and then they want to do 5 minus 3 times negative 6. And again, make sure to always use those parentheses. It does turn into a order of operations problem now. So we have g of negative 6 is equal to 5. Here we've got multiplication. Negative 3 times negative 6 would be a positive 18. And then one last step is to combine, and we would have 5 plus 18 is 23. Okay, so there we go. And this still represents an x-coordinate and a y-coordinate. It's just for a different linear function. So again, we could still plot it if we really wanted to. So negative 6 and 23, let's say, is up there somewhere. Okay, and we could plug in more values to get more points if we needed to graph it. Okay, or we could use the slope-intercept form to graph it as well. But just to get a visual of what these values mean, so this is an x value, and then this 23 is a y value. All right, so continue evaluating our g function. All right, so our g, let's go ahead and let me go ahead and box it so I can see it a little better. There's a lot of kind of writing going on now. Okay, so and I can scroll just a little bit still. I might need to rewrite them in a second, but let's work with that. So we've got g of negative 1/2 is equal to, all right, well, 5 minus 3, and then change that x into negative 1/2. All right, and then now let's continue with our order of operations. So we've got g of negative 1/2 is equal to 5 minus, well, minus a negative will become positive. 3, and when we do have fractions, you could always put the 1 under the 3 to multiply. So 3 times 1 is 3, 1 times 2 is 2. So it would become 3/2. There we go. And then it's mostly your option. If you do want to change it to decimals and work with it, you can. Often kind of the general rule that we use is if they use decimals, like on number 3 here, they use the decimal. So I continue with decimals. If they use fractions, often they want you to continue with fractions. But again, it's your style most of the time. You could do it. You can change it into decimals if you want to. But I'm going to go ahead and continue with this in fraction form. So at this point, we do need a common denominator. That 5 does have a 1 under it, and it does need to become a 2 in the denominator. So we'll multiply both the top and bottom by 2 then. So we'll have 10 over 2 plus 3 over 2. And then that way we can get our answer, g of negative 1/2. Looks like it would be 13 over 2. Okay, so that's how we could evaluate that one. Okay, so it's still just order of operations. As long as we're comfortable with the notation, most of the time it's pretty quick to do these linear evaluations. All right, for number 6, they use the letter T. So they can change it into letters if they want to. It doesn't always have to be numbers. It's still done the same way. So they're still saying wherever you have x in this first problem, change it into this T. So the left side's already done. Right side would be 5 minus 3, and then times it by t. And then here's what's usually good about letters. Let's write our answer. 3 times t is 3t. So that's it. So our answer is 5 minus 3t. So it doesn't always have to be numbers. So this might be useful in case the time is changing, and from there then we could plug it in. Okay, so but sometimes they'll just use regular old letters. Okay, which actually, again, it's kind of nice. You don't have to do as much math. Okay, and then our last two here, where they made it a little bit more complicated with our both functions are involved. Okay, so let me go ahead. I can't see them. Let me write it to the side. So f of x equals 2x minus 7. So I'm just going to put that over here so we can use them. And then g of x is 5 minus 3x. Okay, so I don't have to scroll each time. Okay, so let's scroll and get this ready. All right, so what we'll do, let's color code this one. So f of 3 right here is using the f function. I'm just going to use these. I'm going to do it all in blue. Just give yourself plenty of space. And it still is saying, hey, this 3 is going into that x and that x. Okay, so we're just going to use f of 3 is equal to 2 times 3 minus 7. Let's go ahead and put our equals right there. So our f of 3 is equal to the 2 times 3. So we replace the x with 3. And then we do have a plus. And then we have our g function, which is telling us change those x's into 2's. So on the left side, we've already changed it to 2. On the right side of the equals, let's set it up in our pink or purple. We've got 5 minus 3 times 2 in parentheses like that. And I'm just using a big bracket for organization. Okay, so that way, it's also actually, they are implied. So in case this is minus right there, it will distribute. But for now, let's go ahead and keep it as is with the colors. So let me keep using my color notation. So now it is still simplify inside each bracket. So 2 times 3 is 6. And then we'll minus 7. And then we still have plus 5 minus 3 times 2 is 6. Like that. And then since we can simplify entirely in those parentheses or brackets, 6 minus 7 is negative 1. And then plus 5 minus 6 is also negative 1. And then we've got negative 1 plus a negative 1. That we can simplify all the way to get negative 2. Okay, so that's it. So it's really, so if they give you multiple functions, it really does become just 2 problems in one, and then eventually simplify. Okay, so for our last one, it's back to letters. So let's still use the colors to break it down. Okay, so still, let's go ahead and set up our equal. So this is our left side, equal to, since we can't really fit it in one big line, equal to, let's set up our blank bracket. So they're saying n squared needs to go into those x's again. So I'm just kind of bolding it a little harder. So we've already done on the left side, so n squared's already in. And then we need to do it to this right side, so 2. And then n squared minus 7, just like that. And then afterwards, there's a minus. And then let's use this bracket, which again is going to be needed here in this case anyway. So we've got minus, and then they're saying change the x's that you have in your g equation to n squared. So the left side's already been done. This on the right side needs to be changed. So 5 minus 3 times n squared like that. And then now that we have the setup, let's continue simplifying. So in this blue bracket, so 2 times n squared would be 2n squared. And then minus 7 is attached. And then we have minus, in the purple, 5. 3 times n squared is 3n squared, so it'd be minus 3n squared. Okay, and then inside the blue parentheses, these are not like terms, so they don't combine, so there's nothing else we can do with this in the blue. And same deal with the purple. These are not like terms, there's nothing else we can do. However, because we cannot simplify any further inside these brackets, we would want to distribute to get rid of the brackets. So I would technically have a little plus positive 1 in the front of this blue one, which would distribute. So that way we can get rid of the bracket. And then this negative distributes into the purple brackets. And so what's going to happen is we would have, so positive distributes, which leaves us with 2n squared minus 7. And then this minus distributes, so that 5 would become minus 5. And then the minus 3n squared would change to a positive 3n squared. And then now we can simplify because we have no more brackets and we can combine like terms. So let's use some colored highlighters. I'm just going to use yellow. So the 2n squared plus 3n squared. So 2n squared plus another 3n squared. We're just adding the coefficients. So that is 5n squared. And then the minus 7 and the minus 5, well, negative 7 minus 5 would be minus 12. And then that's as far as it can go. That's as far as we can simplify. So that means that is our final answer. Okay, so this is doing evaluations. So most of the time it is with numbers. But if it is with letters, I mean, don't freak out. It's done the same exact way, done the same exact steps. So just we have to maybe simplify a little bit differently at the end. But other than that, it is all the same. Okay, so thank you for watching. If you do have any questions, please let me know. Otherwise, I'll see you again next time.